Hi, this video is a sneak peek into the Android Graphic Analyzer Eclipse plugin, which is developed by Toolkeen. Android Graphic Analyzer enables Android OpenGL code optimization. The Optimized OpenGL application can be a game, a map, or any other UI application. The Android Graphic Analyzer plugin intercepts the OpenGL calls that the application makes and collects real-time usage and performance information that will help debug and solve performance bottlenecks. Android Graphic Analyzer is demonstrated by attaching it to the Android OpenGL example API demos, delivered with the Android SDK. On the right, you see the Android emulator. I scaled it down to about half of its original size, so that it will fit better in this video. On the left, you see the Eclipse IDE in debug mode. The Android Graphic Analyzer plugin is already installed in the IDE, and the API demos are attached to Graphic Analyzer. The details of how to install the Eclipse plugin and how to attach the Android phone application to the Graphic Analyzer are demonstrated in another video. I access the plugin by selecting the Window command in the top menu, then select Show View. Then select Other. Scroll down until you get to the Toolkeen folder and select the Android Graphic Analyzer. The top part of the Android Graphic Analyzer view is the measurement table. It contains the current value, average value, minimum, and maximum of every measurement tracked by Android Graphic Analyzer. You can restart the statistics collection by pressing the Refresh Statistics button. When I press the Refresh Statistics button, the collected history is replaced by the latest measurement. Therefore, the average value, minimum, and maximum become the latest current value and are later replaced by the minimal, maximal, and average values from this point onwards. It makes sense to refresh the statistics when moving to a different scene in a game, for example, in order not to average unrelated scenes. I will use this button when going from one demo application to another. The first application I am going to analyze is the cube. You can see that every cycle the cube application calls for one draw command that sends to OpenGL 312 triangles. Where does the number 312 come from? A small calculation shows the application draws 26 cubes. That is all the cubes beside the inner one, each having 6 faces. Every face has 2 triangles. Therefore, 26 times 6 times 2 are 312. The second application I am going to analyze is the textured triangle. When I press the Refresh Statistics button, you can see that every cycle it calls for one draw command, which sends to OpenGL one triangle strip containing one triangle. This is indeed a very simple application, and I will use it to demonstrate the OpenGL suppress modes. The OpenGL suppress modes are selected using the combo box on the bottom left part of the plugin view. By default, nothing is suppressed, and all the OpenGL commands are active. This is the current setting. Before we start suppressing OpenGL commands, let's examine the current frame time. The frame time here is the duration in milliseconds between 2 consecutive frame start times. Since Android is a multitasking operating system, many other operations happen between consecutive frames. Another task might get CPU time, or the memory garbage collector might step in and recycle memory. For pure application time measurements, I recommend using the minimum frame time field, which corresponds to the maximum frame rate field. However, to get a realistic view of the frame rate our application is going to get, examine the average frame time and frame rate fields. The maximum frame time and minimum frame rate are a good indication of the worst case scenarios. By selecting a different setting in the Suppress combo box, the Android Graphic Analyzer suppresses or prevents a selected set of OpenGL commands from being performed. Suppressing OpenGL commands shortens the frame time and allows detection and isolation of graphic performance bottlenecks without changing anything in the application. There is no need to modify anything in the application code to perform these experiments. Obviously, suppressing OpenGL commands causes the display to look corrupted and abnormal, but it is only temporarily used to measure the frame time change, and the display returns to normal when I select the Suppress None mode. Let's examine the suppress modes. First I will suppress the clear command that wipes the display buffer before drawing the next frame. This means that the next frame will be drawn on the last frame image. You can see that the image contains the remains of many previously drawn triangles. Every time a suppress mode changes, their measurement statistics refresh automatically, without pressing the Refresh Statistics button. I will let the statistics stabilize. You can see that the minimum frame time is slightly lower. This means that the clear command is very short. Here is a tip for you. You can skip the display buffer clear command only if you are certain that the next frame will fill every pixel on the screen. In games that use a complete skybox, it is possible to skip the display buffer clear. I will return to normal mode. Next, I will suppress the drawing command that sends OpenGL primitives to the scene and let the statistics stabilize. You can see that the minimum frame time is reduced significantly. The screen is blank with gray color because it is cleared every cycle. The frame time is determined by the clear command, the application logic, and by non-graphic OpenGL commands like matrix loading and multiplication. The amount of time saved is the time it normally takes the application to draw this scene. I will return to normal mode. Next, I will suppress all the OpenGL commands and let the statistics stabilize. You can see that the minimum frame time is reduced even more. The screen toggles between two triangles. The only graphic operation that happens here is flipping the front and back buffers to the screen. No OpenGL command is actually executed. The frame time is determined just by the application logic and by the time it takes to flip the buffers and start a new cycle. The amount of time saved is the time it takes OpenGL to perform all the operations needed to draw the scene. I will return to normal mode. To summarize, Android Graphic Analyzer is an Eclipse IDE plugin created by Toolkeen that allows analyzing, profiling, and debugging the graphic OpenGL performance of your application. By using the Android Graphic Analyzer, you will be able to tune your application to the Android environment and to optimize frame rates. For more information, visit toolkeen.com or send an email to info@toolkeen.com. Thanks for watching!